We're going to go over complex data models today, unless there are questions about identity. Any questions about identity? Okay. We will go over then complex data models. If you notice, all the examples that we've done so far have been on single table databases, or that's not 100% true. We had a couple examples that had more than one table in the database, but we did not build the relationship between the two tables. And clearly with databases, you know, the word for databases is the full name is relational databases. The relationship between different elements of the database is critical to a database being workable and successful and bring about all its advantages. So we're going to go through this tutorial about how to do complex data models in ASP.NET. And this tutorial you can find here. I just moved it up before class today. It is in the week 9 module, tutorial, complex models, including foreign keys. You click on that. You go here. If you want to download the finished version, which I did, you click on this. That will take you a long time to download. I'm not as smart with God, what is this called? GitHub. That I should be, but I was only able to see how to download it by going up to the root. Whoops. Where did I go to download it? Oh, here, this one has the code button. So I downloaded all the examples and then pulled out the one that I wanted. So if you do download it, it does take quite a while to download it, but I do have it. I would suggest you go through this tutorial on your own. What I'm going to look at today in the interest of time is the end product. All right. But the steps in getting there is something that you ought to review on your own. So work through this tutorial. The idea of complex data models refers to data models where there's more than one table and there are different relationships between the table. This talks about one-to-many relationships in ASP.NET Core. So this is supplementary material that you can watch to get an idea of how this works. Now, as far as relationships in databases, there are 3 types, but there's one that we're most interested in. And I'll explain to you why we're most interested in that one. First one is a one-to-one relationship. That would be where one member of the first table relates to one member in the second table, and one member in the second table relates only to one member in the first table. An example of that is if you had a person table and driver's license table. All right. One person could only have one driver's license. All right. A given driver's license is only associated with one person. It's not like you can have a joint driver's license with 3 of your friends or something like that. So you have one driver's license. A person has one driver's license. The driver's license only is associated with one person. That is a one-to-one relationship. One-to-many is where you have one thing relates to many things in a related table, but each of those many things only relates to one thing in the first table. An example of that would be the relationship between an order and the line items on the order. In other words, if I go and place an order at Amazon, I might order 5 different things. So my one order has 5 items associated with it. Each of those 5 items, however, is only related to that one order. It's not related to your order or even another one of my orders. It's related to the order that is the parent, so-called, of those items. Another example would be between customer and order. One customer could have many orders, but each order is only associated with many customers. Or each order is only associated with one customer, I said the exact wrong thing. Many-to-many is where you have one row in a table related to many rows in a related table, and each of those rows in a related table can relate to many rows in the first table. An example of that would be the relationship between students and courses. All right. One student can be enrolled in many courses. One course can contain many students. That's a many-to-many relationship. Now, one important thing in identifying these relationships is to go both ways. In other words, if I'm doing the relationship between, let's say, customer and order, I have to come up with statements. One customer has how many orders? One order has how many customers? It's important to look at it both directions to really get the exact cardinality. This is called the relationship. In other words, if I say, well, one customer has many orders, well, does that make it a many-to-many relationship? No. I have to look in the other direction. How many customers does a single order have? It only has one. So you have to ask in both directions. And in database terms, any number greater than 1 is many. All right. Now there's more detail in these relationships. Like, for example, there could be an optional relationship. Like in our first example, there might be a person that doesn't have a driver's license. So there'd be a row for them in the person table, but no row in the driver's license table. That's okay. All right. But if they do have a driver's license, there can only be one of them. All right. If we're going to look at the relationship between students and courses, again, we have to look back both ways. One student can have how many courses? One course has how many students? And if you look at it in both directions, I think you'll find that it's many-to-many. Now, I said one of these is going to be the most important for us. The one that's most important for us is the one-to-many. Why do I say that? One-to-one is rare. I was really happy I found the driver's license example because that's a good example of a one-to-one relationship. All right. But most relationships, if you really think about it, would be many, one to many or many to many. For example, let me think of an example. The relationship between department and dean, for example. You might say that's a one-to-one relationship, but could one department have more than one dean? Could there be co-deans? Yeah, there sure could. Could there be one dean who was the dean over a couple of departments? Maybe. When you're looking at these, you sort of have to look at worst case scenarios. So the question is, how many can they have? Not necessarily how many does one individual have. For example, if you're doing between student and majors, one student can have how many majors? One major has how many students? You might be tempted to say, well, one major can definitely have many students, but one student typically only has one major. But you'd be incorrect to do that because it is possible for a student to have more than one major. All right. So you're not going to build your database based on what is usually true. You're going to build your database based on the possibilities. And it is possible, and it's not rare, that a student could have many majors. You could major in networking and programming if you wanted to. Now, as far as many-to-many relationships, the reason we're not terribly interested in those is because many-to-many relationships become two one-to-many relationships. So if I have a course and a student table, I will have a course ID with all the course information, a student ID, and all the student information. And then I'm going to have an enrollment table that's going to match up what student and what course go together. Remember, with the primary key, could only be one occurrence of that. However, since this is not the primary key, we can have the course ID in there multiple times. We can have the student ID in there multiple times, and that's allowable. So these are the ones we're really going to focus on. One-to-many relationships, because there are very few one-to-one relationships, and many-to-many relationships become two one-to-many relationships. Now, how do we implement this in a database table? Let's say we have orders and customers. Let me write this the other way. Customer is going to have a customer key. Customer ID is the primary key. And then it's going to have all the customer information. The order table is going to have the order ID. As the primary key. All the order information. and it's going to have a foreign key. That is, it's going to have the customer ID that matches up what customer this order can be related to. And that's valid because one customer could have many orders. One order, however, only has one customer associated with it. This is sort of a formula. When you have a one-to-many relationship, the many side gets the key of the one side, because each of the many rows in the database that relate to that are going to point back to the same customer. All the many things can point to the one customer that is the parent of that order. Whereas it's difficult and impossible, according to the normalization rules, for a customer to point to all the orders via a column in the database, because there's many of them, and we don't have repeating data fields in our database. So that's the formula. Do this, whichever one is on the many side, that gets the foreign key of the one side. All right. So I hope this is largely review. Let's review a little bit about what a foreign key is. A foreign key is a pointer from one field to another. But it's more than that. A foreign key forces what is called referential integrity. What is meant by that is I cannot put an order in the order table that does not have a valid customer ID. So my customers were customer 1, 2, 3, 4, or 1, 2, 3, and 5. I could not put an order in there with the customer ID of 6 because there's nothing that matches up to it in the customer table. Now, depending on other parameters, I might be able to leave that empty, might be able to leave that null, but I can't put an invalid number in there. Also, if I delete a customer, do I delete all their orders? That's called cascading deletes. And you can set that parameter true or false depending on the table that you're concerned about. All right, now let's go and look at how this plays out in ASP.NET Core. As I said, I downloaded all that stuff from GitHub. I found the one that I want, and I'm going to open up this application. Now, one disclaimer, and I was trying to get in here before class to try this out, but it took so long to download it that I wasn't able to. When you transfer a project from machine to machine, sometimes there are problems. All right. I experience that when I'm grading your stuff. Something about the configuration of your machine versus my machine. Sometimes, because there's all these other libraries involved, sometimes there's an issue. So if I ran this right now, let's run it just for the heck of it. If I were to run this right now, ideally with the NuGet package manager, you can't see the bottom of the screen, but it's going to load and update some of the files that it's missing. If I go to run this, I'm going to get an error because I do not have the database installed. I've not updated the database, so the database is not on this machine. In fact, that's what I get. That's a different error than I expected. I hope this doesn't lead to problems. Let's go in and update the database though, and we're going to update that the same way. I'm going to go into external tools. No. I'm going to go in under NuGet Package Manager. I am going to create or add migration. It's going to do its thing. And then I'm going to update the database. All right. Let's run this now and see if we get any more luck. And we do not. Let me actually see if another version of that runs, because I noticed there were multiple versions of this. So I'm trying CU30 instead. And let's open that guy. If you get an error that says IIS, click the little arrow and change to the project. Ah, there we go. All right, the home page is okay because this doesn't do any database access. As soon as I go to the students table, though, that's the error I wanted to. All right, because it's not able to connect to that database because we didn't create the database. So let's go and do that. I'm going to again add a migration. So the bottom line is pick the CU30 to use the Entity Core version 3. Succeeded. Doing a bunch of stuff. Creating all the tables. I believe it even initializes the tables. I run it again. I go into students, and away we go, and we have students. You know how happy I am that that popped up error-free. I don't want to have a repeat of what we had a few weeks back. So let's spend a few minutes playing around with this and specifically looking at things that are different than what we did previously. All right, students, we kind of done something like this already. A list with details, edit, click edit. We go in there, we can edit the students' details. We delete, we can delete it. We go to details though, here's something new. It shows data from a related table underneath that for this student. So we're not just pulling data from the student table, we're pulling data from the enrollment table as well. So that's something new. Let's look at courses. All right, there's a course, details, edit. There's a drop down for the department. So instead of having to know the code for department, we actually have a drop down. That's something new. I think that's the only thing new in this area. If we look at instructors, our basic list is different. Not only does it show the instructor information, it shows the courses that that instructor is assigned. And one better, when we click on select, it shows me the students that are enrolled in those courses. First, it shows us the courses, then we can see the students that are enrolled in those courses. So this goes a lot deeper than just one table at a time. Let's see if there's anything special about departments. Not really. Okay, so those are the differences. All right. It's always a good idea when you're approaching any problem or when you're studying an example is to go through it and look at the stuff that you've seen before, look at the stuff that you haven't seen before, look at stuff that you kind of did, and make assessments that way so we can attack it one at a time. Now, let's look at the models for these entities. Because you'll see in our database, if we look at the database, I believe it's this database, CU99. We'll notice that it has a bunch of tables. Course, course assignment, department, enrollment, instructor, office assignment, and student. Let's look, for example, at enrollment. We did not do anything in the database directly. All we did is we created a migration and we updated the model. And yet it creates this database table for us. It knows it based on certain things. For example, if it sees something that ends with the table name .id, it assumes that's the primary key. If there's something that is the name of another table with an ID, it assumes it's a foreign key. So, enrollment table has a field called enrollment ID. The model is smart enough when it updates the database to create a primary key called enrollment ID. Likewise, since there's a course ID and a student ID in there, it's smart enough to know, and it creates those as foreign keys. So let's look at the model. Let's start at the course table. All right. We've seen some of these data annotations before. Some of them are new. But definitely the stuff down here is new. Okay. I'm not going to spend too much time on these fields because we've done stuff like that before. But when we start getting into the relationships, let's think about the course and the relationships that it's involved in. The course is involved in 3 different relationships. There's a relationship with the department. In other words, Calculus 101 is offered by the mathematics department. There's no courses offered by 2 departments. Soccer is offered by the phys ed. Java programming is offered by CISS, and so on. So, what does that relationship look like? It's a one-to-many relationship, whereas one course has one department, and one department could have many courses. So there's a one-to-many relationship between department and course, with department on the one side and course on the many side. How do you create a foreign key then? Where do you create the foreign key? You create it on the many side. So in the course model, I have 2 things to implement that relationship. I say that there's going to be a field in the database called department ID. And also, I'm going to have associated with the course a department entity. So one of these contains one of these. That gets to be really cool. All right. Why does that get to be really cool? Let's peek ahead a little bit, and look at the course list, the index. We can use dot notation to get to the department name. In other words, for each item in models.course, we want that item's department's name, the name of the department that belongs to the course. So we use this dot notation. We don't have to do any linking of tables or anything. Well, let me rephrase that. We don't have to do anything fancy. We can simply grab that department that's related to that course. Now, the second part of it is a little more complicated, because each course has 2 collections associated with it. It has a collection of students, and it has a collection of instructors. Can I put a student ID in this table? No, because a department, or a course, I'm sorry, not a department, a course can have multiple students. All right. How do we get to the student then? We get to it through the enrollments table. This is the classic many-to-many relationship. Right here. Yeah. Course to student is a many-to-many relationship. One student can have many courses. One course can have many students. Therefore, we have this: a course ID in the course table, student ID in the student table. Then we have a separate enrollment ID, which is in the student, which contains the student ID and the course ID. And therefore, in the model, we specify that there's many students for this one course by saying there's a collection of enrollment entities. The enrollment entity is defined over here. Where we specify an enrollment ID as a key, has a course ID, has a student ID, and has associated with it a course and a student. And then has an optional parameter called grade. In other words, students might not have a grade in every course, you know, if courses going on at the time. So let's look at this relationship closer, and let's look at it again. The course relationship has a collection of enrollments. Why does it have a collection of enrollments? Because there's many enrollments. Many people are enrolled in this course. There's many enrollment records in this course. Why does this not say student? It doesn't say student because there's actually a many-to-many relationship. And therefore, we want a collection of enrollment records, not a collection of students. Now, we can get to that collection of students through we can get to an individual student through the enrollment entity, because each enrollment entity has associated with it foreign key for student ID and a student entity contained within it. So I can say enrollment.student.name and get for this course, for this particular enrollment, the name of the student associated with that enrollment record. Same thing in this enrollment pointing back to course. I realize this is a little confusing. This confused me the first time through. So watch the video, all right? And we're going to take our time with this. I think we're covering the same example next week as well. Course is the same. Oh, course assignments is the same as enrollments, except it is for professors. We have potentially a matchup between course and instructor ID in this table. There's an instructor ID and a course ID, which are your foreign keys. And then also we have this entity of an instructor and a course. These are sort of your models for doing one-to-one and one-to-many. For one-to-many, we do this, just like we did with department. We put an attribute for the foreign key to the one side. We put in a single department entity in the model on the many side as well. On the department side, we have, amongst other things, we have a collection of courses. The department gets a collection because the department has more than one course. The course gets the department ID and the single instance of department simply because there's only one department associated with the course. Any questions about this? Let's go on and look and see how the other tables fit in. Course assignment. Well, course assignment relates to teachers being assigned to a course. Course ID and instructor ID, all right, are attributes. This has associated with it because this enrollment points to one instructor and it points to one course. So this is the intersecting table between the many-to-many relationship. Let's look at the table that got created. It's smart enough to know that it is an intersecting table, and therefore it creates both of them as being the primary key, and it creates a foreign key to their respective tables. So course assignment is a good example of an intersecting table. Anytime you have a many-to-many relationship, you'll have something like this table or something like the enrollments table, which is another example of a many-to-many relationship. Each course assignment is associated with a single instructor and is associated with a course. Each instructor, however, as you might imagine, has associated with them a collection of course assignments, because a professor and instructor can have more than one course. And we saw on the course side, we will also say that a course can have a collection of course assignments in it. Department, I think we already looked at. All right. This is both on the one side and on the many side of two different relationships. The administrator of a department only has one administrator, so there's a single instance of it, but it can have many courses, so there's a collection of it, of courses. This question mark means it's optional. If we look at instructor, an instructor can there's no connection back from the instructor to the department. Enrollment is just like course assignment, with the exception that there's a few extra fields in here. Because each enrollment record contains a course, the course that's being enrolled in, and the student that's doing the enrolling, it has one of each of these. Whereas both the student and the course have a collection of these enrollment records. Instructor table. Instructor can have a collection of course assignments. They can be assigned to teach many courses, and only has one office assignment. Notice that it only has it does not have a collection of instructors. Therefore, the relationship between instructor and offices is 1-to-1. One instructor has one office contains one instructor. That's designated by the fact that this is the primary key in both tables. And if we look at the database that got generated, we notice that the primary key is instructor ID and the data value is location. So this example shows all the different instances of cardinality. The one-to-one relationship, if you need to look up how to do a one-to-one relationship, that relationship is between the instructor and the office assignment. So that is a one-to-one relationship. If you want to see a one-to-many relationship, the relationship between department and courses. A department has a collection of courses, Each course only has a single department. And finally, if you want to see a many-to-many relationship, you will look at the course, the enrollment, and the student entities. The course has many enrollment entities, as the student does. And each enrollment entity, however, points to only one course and one student, respectively. So this is how you do the model first approach to relationships. This gives an example of all the things that, all the different kinds of relationships that you can have. Not necessarily, I mean, there probably are things that aren't covered in this example, but of the basic three kinds of relationships that can exist between tables in a database, this sort of covers them. And therefore use this as a sort of guide. You don't need to do this for your lab next week. For this, you just need to do identity. So I wanted to get a little ahead of the game. So this you can do identity. So that is due next week. The following lab after that will involve creating multiple tables and then having an association, a relationship between them. Now, we're not done with this example yet. All right. I would encourage you to review this example. In fact, you know what I'm going to do? I'm going to just upload the one file so you don't have to go sift through all the stuff that I went through. All right. Go through that example and review the way the models are set for those different kinds of relationships. Next week, we're going to look at the code, because the code is a little more involved, as you might imagine, when there is multiple things involved. We might actually go, after we've looked at the original, we might go and delete some of the pages and scaffold to see what part gets scaffolded and what part doesn't get scaffolded. Any questions over any of this? This is really where the fun starts. I know I said that before, but this is where more fun starts. All right. Also due next Wednesday is the design for your database, for your project. So if you haven't thought about that, now is the time to start thinking about that. Any questions? All right, that's all I had. We'll see you next week.